When Voyager 2 launched, humanity still knew very little about the outer reaches of the solar system. The distant planets remained mysterious worlds seen only through telescopes, while the space beyond the Sun's influence existed mostly in theories and mathematical models. Scientists had never observed Neptune closely, had no direct exploration of interstellar space, and only limited ideas about what waited beyond the heliosphere. Despite those unknowns, engineers created a spacecraft built not for luxury or advanced computing power, but for endurance and precision. By modern standards, its technology was extremely limited. Its memory was tiny, its commands carefully planned, and its mission originally focused on planetary exploration rather than surviving for decades in deep space. Yet the spacecraft continued far beyond its expected lifetime. Even after traveling billions of kilometers from Earth, Voyager 2 still sends back data. The signals are incredibly faint, crossing enormous distances before reaching our planet after many hours of travel through space. As it journeyed past the giant planets, every encounter changed scientific understanding. Jupiter appeared far more dynamic than expected. Immense storms, powerful radiation zones, and complex atmospheric systems revealed a world alive with motion and energy. Saturn transformed from a planet known mainly for its rings into a system of remarkable complexity. Its rings were not simple structures but intricate formations shaped by gravity, interactions, and countless smaller bodies. Then came Uranus, unlike any other world in the solar system. Its extreme tilt created a strange planetary orientation, producing seasons and environmental behavior very different from the planets closer to the Sun. Neptune brought perhaps the biggest surprise. Instead of a quiet frozen giant, it displayed violent weather systems and winds moving at astonishing speeds. Massive storms formed and disappeared in ways that challenged existing ideas about outer planet atmospheres. These discoveries changed the image of the distant solar system. What once seemed quiet and inactive became a region filled with movement, change, and hidden complexity. After completing its planetary mission, Voyager 2 moved toward one of the least understood regions ever explored, the outer boundary of the Sun's influence. Scientists once imagined the heliosphere as a smooth protective bubble gradually fading into interstellar space. The transition was expected to be slow and diffuse. Voyager 2 showed otherwise. When it crossed the heliopause, the change appeared much sharper than predicted. Particle environments shifted rapidly. Radiation conditions changed noticeably, and magnetic properties behaved differently than earlier theories suggested. Rather than a gentle transition, the spacecraft encountered what looked more like a distinct boundary separating two different environments. This forced researchers to rethink the shape of the heliosphere itself. Instead of a simple sphere surrounding the solar system, it now appears to be uneven and constantly changing, influenced by interstellar pressures, galactic motion, and magnetic interactions. The combined observations of Voyager 1 and Voyager 2 revealed that this boundary is not identical in all directions. Different regions interact with interstellar space in different ways. Beyond that boundary lies interstellar space. For a long time, this region was imagined as mostly empty. Voyager 2 revealed something very different. Measurements showed variations in plasma density, changing magnetic fields, and wave-like structures extending across enormous distances. These patterns suggest that interstellar space is not a silent void but an environment shaped by events occurring throughout the galaxy. Ancient stellar explosions, powerful winds from distant stars, and large magnetic structures may all contribute to this hidden architecture. Even cosmic rays moving through the region appear affected by these conditions. Another fascinating result involves magnetic behavior near the boundary regions. Scientists expected highly chaotic interactions where solar influence met interstellar conditions. Instead, some transitions appeared unexpectedly organized. This raised questions about whether large-scale magnetic structures across the galaxy possess more order than previously believed. If confirmed, it could mean interstellar space behaves less like random turbulence and more like a connected system shaped by processes operating over immense distances. Voyager 2 continues moving outward. Its power source slowly weakens, and several instruments now operate with reduced capability, yet valuable information still arrives. Occasionally, unusual measurements appear. Small particle increases, temporary magnetic changes, and subtle plasma variations continue to provide clues about this unexplored region. Rather than revealing emptiness, the spacecraft keeps showing activity. The heliosphere itself no longer appears to be merely a protective shell around the solar system. Instead, it seems more like an active boundary zone where solar influence and interstellar conditions interact continuously. Energy, particles, and magnetic effects move through this region in complex ways. Voyager 2 helped reveal that the edge of the solar system is not truly an ending. It is a transition. The farther it travels, the clearer one realization becomes. Space is not empty. It is layered, structured, and constantly changing. There is no simple line where the solar system ends and the galaxy begins. Only gradual shifts spreading across enormous distances. Even now, decades after launch, Voyager 2 continues its silent journey into regions no spacecraft was originally expected to study for so long. What it records is more than scientific information. It is evidence that the universe is interconnected on scales far larger than humanity once imagined. And somewhere in that immense darkness, Voyager 2 continues forward, carrying humanity's presence into a cosmic frontier that is still revealing its secrets. Far beyond the planets it once explored, Voyager 2 now travels through a region where sunlight has little meaning and the familiar structure of the solar system begins to fade into the wider galaxy. Here, there are no worlds to photograph, no moons to fly past, and no dramatic planetary encounters. Yet some of its most important discoveries may be happening now. The spacecraft moves through interstellar space at enormous distance from Earth, carrying instruments designed decades ago, many operating far beyond their intended lifetimes. Every transmission it sends arrives as a faint signal crossing billions of kilometers before reaching Earth's antennas. And still, the data continues. One of Voyager 2's greatest contributions is revealing that interstellar space is far more active than scientists once imagined. Instead of emptiness, the spacecraft has detected changing particle environments, magnetic variations, and shifts in plasma conditions that evolve over time. This suggests the region between stars is not still or isolated. It moves. It changes. It responds. Researchers now believe interstellar space contains enormous structures shaped by magnetic fields stretching across vast portions of the galaxy. These invisible frameworks may influence how energy, particles, and cosmic radiation travel through space. Voyager 2 offers one of the only direct observations from inside this environment. Its measurements help scientists understand how our solar system interacts with the larger Milky Way. Another important question involves cosmic rays. These high-energy particles travel through the galaxy carrying information from distant astrophysical events. As Voyager 2 moved beyond the heliosphere, scientists observed changes in cosmic ray intensity, revealing how the sun's influence affects incoming radiation. The heliosphere appears to act partly as a shield, reducing some cosmic radiation before it reaches the inner solar system. Understanding this process matters not only for astronomy but also for future human exploration beyond Earth. The deeper humanity travels into space, the more important these observations become. Voyager 2 is effectively exploring that environment decades before humans ever arrive. The mission has also transformed ideas about boundaries in space. Scientists once preferred clear divisions, solar system here, interstellar medium there.